All right, guys, what do we got? Resistive circuit number 13. So this one looks pretty complicated, but let's break it down the same way as we did before. Let's start with putting in our parallel junctions first. So we got a parallel junction there and there. There looks like there's a series combination right here between 6 and 7. So we can add those guys up and we can see that there's 2 kiloohms in that rung there. Okay, next thing, what do we want to do? Maybe we'll start here at this parallel junction. Now I can't do this in my head, so let's just write that down. R4 and 5 is going to be equal to 9 kiloohms times 3.3 over 9 plus 3.3. Okay, so punch that into your calculator, and you'll find the equivalent. Remember, it's got to be less than 3.3, and the equivalent for that is 2.41 kiloohms. Okay, so everything from here down is the same as a 2.41 kiloohm resistor. Okay, next thing we got to do is we've got to add the 6 kiloohms for R2, the 4.7 for R3, and the 2.41 for the combination of 4 and 5. So in your calculator, put in, so let's do R2, 3, 4, and 5 is going to be 6 plus 4.7 plus 2.41. And if you add all those guys up, it gives you 13.11 kiloohms. Okay, so everything from here down is 13.11 kiloohms. Beauty. Okay, at that point, we have two unequal values, 13.11 kiloohms in this rung, 2 kiloohms in this rung. So we're going to do product over sum again, and we're looking for a value that's less than 2 kiloohms. So what do we got? R2 through 7 now we're trying to find. And we're going to do the product over sum of 13.11 times 2 over 13.11 plus 2. So the combination of 2 through 7, when you put it into your calculator, gives you 1.73 kiloohms. Beauty, because we were looking for a value that was less than 2, right? So all of that there is the same as 1.73 kiloohms. And then our total is going to be equal to the 1.73 that we just found, plus the 2.27 that we have for R1. And so total resistance ends up being 2.9, 4 kiloohms. Excellent. Okay, so our total resistance here is 4K. For all these guys, we're finding total resistance and total current. So let's drop in an Ohm's law circle here. This one we're running off of 120 volts. We just did 4,000 ohms. Okay, and we do that, it ends up giving us a current of 0.03 amps. Beauty. Okay, so again, something that seemed complicated when we started this is hopefully becoming a little bit more simple once you find the patterns with the series and the parallel combinations. All right, guys. Nice job on that one. Now stop this one and then move on to number 14.